Welcome to this video presentation by the postgraduate student whose poster it represents. We will miss the bustling crowds around the posters at the All Energy Conference this year, but we hope you enjoyed this online version that we have created. Before the presentation starts, I would like to acknowledge the support of our generous sponsors. Without this support, the competition could not proceed and the winning entrants would not receive a financial award. Our platinum sponsor is the Victorian Government through the Department of Environment, Land, Water and Planning. Its brands include Victorian Energy Compare, Victorian Energy Saver, Victorian Energy Upgrade Program, Energy Scorecard and Energy for Business. Their contact details are on the slide. Monash University's Monash Energy Institute is one of our silver sponsors. With over 170 staff involved, the Institute has a vision to bring people together to solve global energy problems. The Monash student posters in this competition represent some of that work. Baywa Renewable Energy is another silver sponsor. Baywa develops both wind and solar projects in Australia as part of a global energy portfolio. Baywa staff have also supported our AIE events in the past, including our Young Energy Professionals Speed Networking events. Our final silver sponsor is the University of Melbourne's Melbourne Energy Institute. Many of you will have attended their regular forums that keep the energy community and public up to date on technical and policy energy matters, and the University of Melbourne posters in this competition reflect some of that work. Seed Advisory is our bronze sponsor, and this small but well-recognised energy consultancy covers both the technical and regulatory fields. Seed Advisory has been a regular supporter of the AIE and a presenter at our events. Lastly, we thank All Energy for hosting our live poster events over the last decade, and we look forward to doing this again post-COVID. These last slides show you our poster winners in the last competition. And I now hand you over to the poster presentation. Thank you.
Hi everyone, welcome to my presentation. My name is Sasha and I'm a PhD student in MONASH University. My research is about the mechanistic study on the synergistic interaction between individual components during the flash process of wooden biomass. Wooden biomass is one of the most significant renewable fuels for the current carbon-constrained world. Its energy density can be improved further through thermal pyrolysis, which simultaneously delivers three value-added green fuels: biochar, bio-oil, and synthetic gas. Compared to slow pyrolysis that has been commercialized for decades, flash pyrolysis has been receiving increased attention due to its extremely short residence time that benefits downstream in the reactor and hence a significantly improved throughput. Although the residence time is extremely short, flash pyrolysis is still deemed as a complex process. A further addition to the complexity of flash pyrolysis is biomass composition, where biomass mainly consists of three organic constituents: cellulose, hemicellulose, and lignin. In this study, to elucidate the mechanisms underpinning the interactions, efforts were made to arrange the different components and their derivatives such as volatiles and char. More specifically, the aromatic vapors were tested by the model compound to assess how they could affect the cooking of aliphatic structures. This new knowledge is desired to inspire the optimization of the wooden biomass flash pyrolysis process, leading to a remarkable increase on yield and quality of the bio-oil and biogas products. The materials used in this study are cellulose, xylene, and lignin. To mimic the volatiles related from different components, high-purity glucose and picresol were also tested. Flash process was carried out in a pyroprobe system with a heating rate of 20,000 degrees per second, coupled with gas chromatography. To investigate the co-pyrolysis process, samples were put in the reactor in a sandwich manner to study the char-volatile and volatile-volatile interaction during co-pyrolysis process. From the pyrolysis results of the cellulose lignin blend, we found that the interaction promoted the release of volatiles with more bio oil. However, the total bio oil decreased from the volatile char reaction, which means the interaction mainly came from the homogeneous volatile-volatile reaction. This picture shows the co-pyrolysis of glucose and picresol by different methods, among which glucose is a monomer of cellulose, while picresol is a kind of aromatic moiety from lignin volatiles. It's clear that the results are different when the samples were separated and mixed, which confirms that the involvement of radicals in the gas phase is overwhelming in the flash process of raw biomass. Besides, from the bio oil and gas composition, it can be concluded that the picresol could capture the oxygen radicals from glucose volatiles and transfer them into liquid oil, rather than being solidification into char. Therefore, the conclusion is that during the flash pyrolysis, the homogeneous interaction between volatiles is superior over the heterogeneous char-volatile interaction, among which the reaction between radical fragments is dominating. The aromatic moieties from lignin volatiles could capture the oxygen radicals from cellulose volatiles, resulting in more liquid, while inhibiting the polycondensation of radical fragments to char.